adding hydrogen. We call this hydrogenation. Hydration is adding water. Hydrogenation is adding hydrogen. So here we've got hydrogen molecule. This is a symmetric reagent, so we don't have to worry about this Markovnikov business. This is only going to happen when we have a catalyst, because otherwise the reaction is so slow that it essentially doesn't happen. But we get one hydrogen adding to this carbon and one adding to that, and we end up with an alkane. Usually the catalyst is a finely divided metal, such as nickel, platinum, or palladium. And what happens is the metal actually adsorbs the hydrogen gas and weakens this hydrogen-hydrogen bond, and so makes it easier for the reaction to happen. So here we have a picture of the catalyst, and the hydrogen gas is adsorbed to it, and so it does not have the strong bond that it used to have, and so it will add to this double bond more easily, so the reaction will be faster. And usually these hydrogen atoms will add to the same face of the double bond. Remember, double bonds don't rotate, and so there's a top and a bottom, and they're both going to add to the same side. So here we have a cyclopentane. This was cyclopentene, and these hydrogens are going to add to the same side. And so we're going to have these methyl groups be in the cis position. Write an equation for the catalytic hydrogenation of 2-methyl-2-pentene. So pentene is 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2-pentene. Double bond on the second carbon. 2-methyl. Means we've got that one up there. So we're adding hydrogen, and we need a catalyst. Could be nickel, platinum, or palladium. These hydrogen atoms are going to add to this double bond. And so the double bond, when we're doing this in bond line angle stuff, the double bond just goes away. When we're forming an alkane like this, it's not a cycloalkane, it's a straight chain alkane. These hydrogens are adding to the same side of the double bond, but ultimately it doesn't matter because this is a single bond and there's rotation. This is cyclopentene. And
one of those hydrogens add though?
No, they'll both add. They'll both add because the one will add to the double bond. You could think of the double bond as swinging over to bond to that, and then you've got hydrogen with 2 electrons, and that's going to go over here. I don't think that's the actual mechanism, but you can't just add one because then you've got a radical. I think we go into the mechanism of this, I can't remember. 4-methylcyclopentene. So there's cyclopentane. Cyclopentene will have a double bond. The double bond is assumed to start at carbon number 1. I'm just going to number clockwise because that just seems more normal to me. So this would be carbon number 1, 2, 3, 4, and so we've got a methyl group down there. Plus hydrogen. Well, let's call it nickel this time. It's a metal catalyst. These hydrogens are going to add to the same side of this double bond. Is there already a hydrogen on that double bond? I'm sorry, is there already a hydrogen on this carbon? There can't be a hydrogen on a double bond. Does this carbon have a hydrogen?
Yes.
Yeah, it does. Because we see 3 lines here, and there's got to be a 4th bond, and that would be hydrogen, and we just don't draw him. So this one already has a hydrogen, and this has a hydrogen, And so these hydrogens are going to add on the other side, but does it end up mattering? It doesn't, because they're both hydrogens. So this one has 2 hydrogens. Let's do those shadowy characters. So no, this one has 2 hydrogens, and this one has 2 hydrogens. And we had 1 here before. Any questions?